Good morning, my name is Fabio Benedetti. My tutor is the professor Sonia Bergamaschi, and the result of my first year of research is LoadSum, which is a tool able to perform schema extraction and summarization from linked open data sources. My PhD study are positioned inside the project NEAT, which is a multidisciplinary project where skill coming from ICT, legal, and bioethics collaborate to build a knowledge network for e-health. In this project, my task is to study, analyze ontologies and vocabulary in the medical domain in order to develop a new algorithm for the creation of dynamic vocabularies by a given context and develop new technique of keyword search. First, I started studying the most important ontologies in the medical domain as SNOMED CT and UMLS in their native format for the first OWL and for the second RRF rich release format. Using those resources in their native format, I encountered some issues. First of all, those resources are very static, and it is difficult to integrate those resources with other vocabulary in the web. And RRF is a proprietary format used only in UMLS. So, for this reason, I searched this resource in the world of linked open data. This format gives me some advantage. First of all the data contained in those resources are described using the same language, RDF. Those resources are highly connected and mapped together by experts, and exist in this context many hub sites which collect dataset, homogeneous dataset according to their domain. For example, Bioportal contains more than 2,000 ontologies and vocabulary in the medical domain. Also in this context, I have encountered some problems. First of all, there doesn't exist a best practice in the schema definition for those kind of resource, and in many cases the documentation of datasets is very poor. So the user wasted a lot of effort only just trying to understand which kind of knowledge is contained in those resources. For this motivation, I started to develop LoadSum, which is a tool able to analyze and extract synthetic information from a generic data set. This is the architectural overview of the tool. As you can see, is divided in two main modules. On the left, there is the schema extractor, which taking input the URL of an endpoint Sparkle and produces as output an expanded schema. On the right, there is the schema summarizer, which taking input the expanded schema and a parameter n supplied by the user to produce the schema summary. The first module is the schema extractor. Its goal is to extract information about the schema and other statistical information that will compose the expanded schema. It takes advantage of two characteristics in common with each linked open data dataset. The data contained in each dataset is described using RDF. In particular, RDF data model is an evolution of a graph data model in which the structure used for describing data is implicitly contained in the data itself, so can be easily extracted. Another characteristic is that each endpoint is queryable through Sparkle query language. Recently was released the version 1.1 of this standard that introduces some important features of aggregation as group by and count that are widely used in the process of schema extraction. The schema extraction module is composed by 3 components. The first is the query generator that generates the query required by the other 2 components. It is able to produce query of different complexity according to the request of the other component. The endpoint validator only verifies the soundness of the RDF dataset, and the last component, the schema builder, is the core component of this module. It has the goal to extract the information about the schema and other statistical information that will compose the expanded schema. It contains an algorithm capable, able to interact dynamically with the data set. It is able to handle some kind of errors, and according to those errors, he provides a different strategy to extract the information that it needs. The expanded schema is a bipartite graph. This is a small example where the nodes are divided into groups. On the left, there is the subject nodes, and on the right, subject classes, and on the right, the object classes. The edges are directed from a node in S to a node in O, and represent the existence of properties between instances of a subject class and an object class. Additional information is contained in 2 values. The first IC is associated with each class, represent the number of instances of this class. And the second IP is associated with each property and represents the number of times this property is used between 2 classes. This is a summary of the result of the test on the schema extractor. I have tested this algorithm with 182 datasets. Of those, only 100 are compatible with the Sparkle 1.1, but of those, the 84% completed the process of extraction. In the table, there are some numerical value about the extraction of 3 different ontologies. You can see that when the number of error is 0, the time of extraction is very low, less than 1 minute. But when some error occurs, the time of extraction increases. The second module is the schema summarizer. It takes an input and the expanded schemas and a parameter n that represents the number of classes that will compose the schema summary. It is composed by 3 components, 2 ranker and a rank merger. And his goal is to produce a schema summary highly representative of the dataset. The first ranker is the important ranker. A class in an ontology is important if is central in the ontology and if its instance are connected with a high number of instances of other classes. I have adapted an existing algorithm to implement this ranker called Salsa, which is an evolution of its algorithm. This algorithm was commonly used for ranking web pages. The second ranker is the coverage ranker. A coverage of a class represents its ability to of this class of reaching the neighbor nodes within the graph. This rank, I have implemented this ranker through an iterative algorithm, and the last component is the rank merger that taking input these two partial rank and put them together through this simple formula. After that, this component extract the top n classes ordered by this global rank, and those classes will compose the summary. Thanks for your attention. Your man at your disposal for any question.